Now, in order to understand what a greenhouse gas is, we need to make sure that we review a couple of things. We need to review the biosphere. And the biosphere includes all parts of Earth that host life with all of its organisms and its environments. Now, life is going to rely on these stable temperatures in order to support this biosphere. So what specifically is a greenhouse gas? Well, greenhouse gases are gases that absorb heat in the atmosphere. And they're going to be gases that are going to go through and play a vital role in supporting the biosphere. Now, we're going to look at greenhouse gases like water vapor, methane, and CO2, but greenhouse gases help maintain a stable temperature on the surface of the planet. Now, greenhouse gases are going to play an important role because they're going to keep the environment at a stable temperature. Now, we can use a greenhouse as an analogy to go through and understand how greenhouse gases work. When sunlight hits a greenhouse's surface, some of the heat is going to radiate back into the atmosphere. However, some of the heat is absorbed and trapped by the glass of that greenhouse. We call this the greenhouse effect, and it helps keep the earth and greenhouses warm. Now, greenhouses at night are going to trap that heat and keep a stable temperature over the course of night and day, so that way the plants and the environment within that greenhouse stay stable. Now, the surface of the earth is going to work in a very similar way. Some of the light is going to get reflected off the surface of the earth, almost like pinball bumpers. However, some of that light is absorbed by the gases in the atmosphere. And when the light is absorbed by the gases in the atmosphere, it's going to contribute to atmospheric heating. And that's what keeps the stable temperature within the environment. Now, without the greenhouse gas effect on the surface of the moon does not have an atmosphere. And the reason that the moon goes through and fluctuates in temperature is because all of the sunlight is reflected back into space. So if we look at the surface of the moon over the course of the day, we can see, because there's no atmosphere, the side that does face the sun is going to reach temperatures of 100 degrees Celsius. And as it goes through the dark side of the moon, it's going to reach temperatures of negative 170 degrees Celsius. This is not really sustainable for a stable biosphere. So as a result, the way that we maintain the stable environment that we see within our ecosystems and biosphere is via these greenhouse gases, and it's going to work the same way that a greenhouse works, but instead of utilizing glass, we're utilizing these different gases. So let's go through and zoom in and look at the specific gases that play and contribute a role to maintaining that stable environment. Now, the three main gases that we're going to go through and look at in the atmosphere are going to be carbon dioxide, water vapor, and lastly here, methane. And each of these gases is going to play different and contribute different roles into how much energy they can go through and absorb. Now, these greenhouse gases, as they go through and absorb heat, are going to reflect some of that energy and radiate some of that energy back into the atmosphere. However, excess greenhouse gases are going to go through and increase the amount of energy absorbed. And when we increase the amount of energy absorbed into the atmosphere, this can lead to excessive heating. So excessive greenhouse gases lead to an overall increase in atmospheric temperature, and that atmospheric temperature then has a rippling effect across the biosphere. And we can think about these greenhouse gases almost like a wall along the atmosphere. When the sun goes through and beams down, some of that radiation is going to get reflected back into space. However, if we increase the amount of greenhouse gases to the point where none of the sunlight can go through and get reflected back into space, and all of the heat is absorbed by these greenhouse gases, what we're going to see is an increase then in global atmospheric temperatures and temperatures across different ecosystems. So why might greenhouse gases potentially be dangerous? Remember, a greenhouse gas is a gas that contributes to the greenhouse effect by absorbing infrared radiation. Now, we can see that as the sun goes through, it's necessary for greenhouse gases to exist to go through and heat up the atmosphere and keep temperatures stable both during the day and at night. However, when we have excessive greenhouse gases, they're going to go through and prevent the dissipation of that energy and continue to increase the global temperature. Now, the best way that I can go through and think about this is a bathtub. This is the bathtub analogy here. If we have a bathtub that's going to go through and flow at 100 gallons an hour into the bathtub, and we have a hole on the outside of the bathtub that allows for 100 gallons per hour to flow out. that's really not going to cause the water level of that bathtub to change. So as a result, the water level in the tub is going to remain the same. However, if we increase the flow even by 1%, so if we have 100 gallons, we multiply that by 0.01, so it's an increase of 1 gallon per hour, what we're going to see now is the water level is going to change. If we have 101 gallons per hour going in and only 100 gallons per hour going out, eventually that bathtub is going to overflow and the water level is going to increase. It's a compounding effect. So the reason that excessive greenhouse gases are going to be dangerous is because they're going to go through and incrementally cause a compounding heating of that atmosphere, disrupting the environment. Now, we as a species contribute to an increase in global temperatures because of the greenhouse gases that we're emitting via the gasolines, the oils, and the fuels that we use for modern life. And we extract these oils and gasolines from underground reservoirs of decaying matter. And we take these oils and gasolines and we use them in our cars and factories, and we go through and we burn them. Now, via the process of combustion, we're going to get gases like carbon dioxide. And that carbon dioxide is going to be emitted as a waste product from the various things that we go through and do, and that is going to increase the concentration of CO2 and other greenhouse gases in the atmosphere. Now, if we look at a graph of CO2 and temperature, we can see here's carbon dioxide over the course of many years and the CO2 concentration over many years within the globe. We can see that this is directly correlated to temperature spikes, and the concentration of that CO2 has a rippling effect on the atmospheric temperature. So how do we go through and maintain and ensure that these environments stay stable? Well, we have to go through and reduce our reliance on fossil fuels and go to energy sources such as renewables, things like wind and solar. If we utilize these renewable resources, these don't go through and contribute to greenhouse gases in the atmosphere. We also need to focus on maintaining our ecosystems and maintaining our tree populations within the environment. Trees and plant life contribute to absorbing carbon dioxide. It's important for us to go through and maintain these stable environments. Now, we as a species are constantly going through and sending satellites out over the Earth to go through and monitor and regulate the quantity of greenhouse gases present in the environment. And we can see from this thermal image here the increase of these greenhouse gases over periods of time. Now, monitoring and understanding the relationship between temperature and concentration of carbon dioxide is important for us to go through and regulate, so that way we can go through and maintain that stable temperature and prevent large spikes in ecosystems. So although these greenhouse gases are important and vital for the environment, it's important that we as a species go through and control and maintain them in order to prevent large catastrophic changes to our ecosystem and, more importantly, our biosphere.